All right, hello and welcome. In this explainer, we are diving into a super fast revision of one of the absolute biggest topics in the GCSE higher tier algebra syllabus, and that is graphs. We're going to cover everything from straight lines all the way to circles, all based on what you need to know for the exam. So here's the big question. Can you really get your head around all the key graph types you need for your exam in just 5 minutes? Well, you know what? We're about to find out. Let's start the clock. First up, the absolute foundation of it all, straight line graphs or linear graphs. If you can master this, I promise a lot of the trickier stuff we're going to talk about will suddenly just click into place. It's kind of amazing how this one simple formula, y equals mx plus c, tells you everything you need to know. The m is your gradient. Just think of it as the steepness. For every 1 unit you go across, how many do you go up or down? That's m. And c, that's the y-intercept, which is just the point where your line crosses that vertical y-axis. Simple as that. The gradient is absolutely key here. For parallel lines, it's easy. They have the exact same m value. They're equally steep, so they're never, ever going to meet. Now, for perpendicular lines, it's a little bit more involved. Their gradients are what we call negative reciprocals. The easiest way to remember it? If you multiply their two gradients together, you will always get -1. I can almost guarantee you'll see a question like this in your exam. They'll give you 2 points, or maybe a point and a gradient, and ask for the equation. Don't panic. It's just a 4-step process. First, you calculate the gradient. Then, plug in a point to find c. And finally, just write down the full equation. If you follow these steps, you are going to nail it every single time. All right, let's step it up a notch. We're leaving the safety of straight lines and entering the world of curves with quadratic functions. So whenever you see an x squared as the highest power in an equation, you know you're dealing with a quadratic. And its graph is this really distinctive U-shaped curve that we call a parabola. It can be a happy U-shape if that a value is positive, or it can be a sad upside-down U if a is negative. For any parabola you see, there are 3 key features you have to be able to spot. The roots, that's where it crosses the horizontal x-axis, where y equals 0. The y-intercept is the easy one. That's just the c value from the equation. And then you've got the turning point, which is that single lowest or highest point before the curve starts heading back the other way. And here's a pro tip for your exam. You don't actually need to draw the graph to find the turning point. Nope. You can find it using algebra with a technique called completing the square. By rearranging the equation, you can literally just read the coordinates of the turning point straight from your answer. It's a massive shortcut. Okay, time for a quick-fire recognition round. In the exam, you've got to be able to identify several other key graph shapes just by looking at them. So let's blast through them. First up, the cubic graph. This one comes from an equation with an x cubed term. Just look for its characteristic S shape. A positive cubic starts low and finishes high, and a negative one does the opposite. Next, this is a reciprocal graph. Y equals 1 over x. See how it has 2 separate parts that kind of mirror each other? A really key feature is that the curves get closer and closer to the axes, but they never actually touch them. We call those boundary lines asymptotes. And now for the exponential graph. Here, the x is actually in the power. This is the graph of really rapid growth. Think of something going viral. It starts off slow and flat, and then, whoosh, it just shoots upwards at an incredible rate. And finally, the trig graphs. Sine and cosine are the famous ones, and they both produce these smooth, repeating wave patterns. We call them periodic because the shape just repeats itself over and over again, kind of like waves in the ocean. So, once you know the basic shapes, you've got to be able to move them around. If you add a number on the outside of the function, like f of x plus a, it just slides the whole graph up or down. And if you stick a minus sign out front, so y equals minus f of x, it flips the entire graph upside down, reflecting it in the x-axis. Okay, so why are we learning all of this? Because graphs are incredibly useful for describing what's happening in the real world, especially when it comes to motion, things like speed, distance, and acceleration. The exam board loves these. They call them kinematic problems. Right. On a distance time graph, the gradient tells you the speed. That's it. A steeper line means you're going faster. A totally flat, horizontal line, well, that means the distance isn't changing, so the speed is 0. You're standing still. Now be careful here. This is a classic mistake. If the vertical axis says velocity instead of distance, the gradient is not speed. The gradient of a velocity time graph tells you the acceleration. That's the rate at which the velocity is changing. But on a velocity time graph, we can also find the distance traveled. It's not the gradient this time. Get this, it's the area under the graph. If you calculate that area, it gives you the total distance. This is a huge concept, and it is almost guaranteed to be in your exam. And for our final section, we're looking at a very specific, very important shape that has its own special rules, the circle. So here's the equation for any circle that's centered right at the origin, the point 0, 0. It's simply x squared plus y squared equals the radius squared. So if you see an equation that says x squared plus y squared equals 25, you know instantly it's a circle at the origin with a radius of 5, because of course, 5 is the square root of 25. And this is where different parts of your maths knowledge really come together. A tangent is just a straight line that kisses the edge of a circle at one single point. And the crucial fact to remember is that the tangent is always perpendicular to the radius at that point. So to find the tangent's equation, you find the gradient of the radius, then get the negative reciprocal, and then it's right back to our old friend y equals mx plus c. See how it all links up? Wow, we have covered a huge amount there, from straight lines to quadratics, reciprocals to circles. But, the real key to mastering these isn't just watching me talk about them, it's about doing it yourself. So the only question left is, which one of these are you going to grab a pencil and paper and practice sketching right now?